Welcome back to another episode of our Honors Geometry videos. We're currently in Unit 2. This is Section 2, the exercise portion. We're going to do 7, 8, 9, and 10 all together, dealing with sometimes, always, never. You see this a lot in geometry. There's a lot of situations where we encounter which are always true, and then sometimes situations where maybe a certain conditional statement is true, but the converse is not true. And of course, sometimes the things are never true. And so it helps us to understand sometimes the properties and the situations that we can see in terms of sometimes, always, never. A lot of times, instead of remembering every single instance of every single case, it's easier just to remember the one instance that doesn't work. Sometimes that helps you solidify a concept a little bit more than trying to memorize all the instances that do work. So let's see what we got. The sum of the measures of two acute angles equals the measure of an obtuse angle. Well, I can certainly think of a case where that is true, and I can certainly think of a case where that is not true. For instance, let's say we have 60 plus 60. Those are two acute angles. 60 plus 60 is 120. That's an obtuse angle. But then we could also, for instance, say 10 plus 10. 10 and 10 are acute angles. 10 plus 10 is 20, which is also an acute angle. So I would say sometimes that is true. If angle XAY and angle PAQ are vertical angles, then either XA and P or XA and Q are collinear. So let's draw this out and see if it's a situation where maybe we can get it to not work. Or maybe we can get it to work. Who knows? So here's angle XAY. Now we know from our angle labels that X and Y are interchangeable. Right? So I could change that to Y, or I could change this to X. A, however, is not going to move. It's got to be the vertex angle there. And angle PAQ. Now it says they're vertical, so I'm going to draw these vertical angles across from each other. So something like that, about as close as we're going to get. So PAQ. Now again, we could flip Q and P. So those are our only options. These are all our combinations of how the letters could look. With A being the vertex that binds those two angles together in order for them to be vertical. So it says either XA and P are collinear or XA and Q. So here we have XA and Q, and in this situation we have XA and P. So no matter where we put those letters, if they flip-flop one or flip-flop them both, one of those two situations is always going to exist. So that would be an always. Number 9, if two angles form a linear pair, then they are complementary. Well, a linear pair is something that looks like this, right? And I'd say that those two angles are definitely not complementary. I'd say they're supplementary. In fact, I don't think these angles are ever going to add up to anything but 180 degrees. So there's no way they're going to be complementary and add up to 90. If a statement is true, then its converse is true. So what it's saying is, if you take an if-then statement, if blah blah blah, then blah blah blah, and you take the converse of it, where you flip the if into then it will always have to be true. I don't think that is true. Sometimes it is. Sometimes we have a conditional statement where if A then B exists, we flip it around and say if B then A also exists. And there's certainly a lot of geometry examples that we can use for that. However, that's not always going to be the case. There's some situations where if A then B is true, when you flip it around, if B then A isn't necessarily true. And we're going to see some geometry examples of that as well. So Number 10 is a sometimes situation. Any questions or need some further elaboration on any of those, feel free to leave a comment. Otherwise, you can like, subscribe, or share to our Honors Geometry videos if you are enjoying them.